Okay. It's great to be here in Kiev. I was here in May also at JEConf. How many of you attended my session there? Okay. Nobody. That's good. Because even though it has the same title, it's not the same presentation. It's a completely new presentation. The demo is completely rewritten and everything is new. So even if you were there, there wouldn't be any problem. So who am I? My name is Ivar. I coded my first Java program, Hello World, in '95. So I've been coding Java all the way. Since '98, I've been doing it professionally, and mostly on the server side, mostly enterprise Java. Also been involved in some mobile development, Android, and web development, but mostly server side. I work for a company called Cybercom. We're located in Sweden. I am Norwegian, but I live in Sweden though. I'm active in the community there, and I also recently joined the expert group for JSR 371, which is MVC for Java EE 8. So if you want to discuss MVC with me afterwards, just I'll be here for the rest of the conference. So today's topic is Spring 4, Java EE 7, and then a combination of the two. So who many of you guys are using Spring? Okay, version 4. Oh, you got to upgrade. You know, and Java EE 7. Yeah, some of you, good. I'll do a short introduction of both of them first. Then I'll see how they overlap, and then I'll dive into the code, and we'll do some demo. So there will be code. So even though if you sleep through the next session, wake up when the demo starts. That's when it gets exciting. So a little history. In '98, JPE was launched, and that is the predecessor to Java EE. And it evolved when they started making J2EE 1.1, 1.2, 1.3, and etc. And it just got worse, right? Everybody who's done any Java EE development at that time, or J2EE as it was called, know the hassle with all the deployment descriptors and every interfaces and everything you needed to do to get your application up and running. It was just getting worse. We were screaming for something else, and the answer was Spring. So in 2002, Spring was announced. And in 2004, we got the first milestone release. And the current version of Spring is now 4.1. And that was released in January this year, or 4.0 in January. 4.1 came in January summer. In last year, in June, Java EE 7 came. And that was a big leap forward. Now Java EE is easy and it's fun again. So, and we'll see how they compare. So first, Spring Framework 4. It's no complete introduction I'm giving now. I'll just pinpoint a couple of things and go through what is Spring and what is new in version 4, and it's just to have some common base when we go into the demo. So this is an overview of Spring. And it's lots of different technologies, everything from aspects oriented through the core container and web support and WebSockets and everything. But isn't Spring just XML? Well, it used to be. And in some moment in time, we were more like XML programmers than Java programmers. And no Java programmers really like XML. So luckily in Spring 2.5, I think it was, we got annotations in Java config. So are annotations better than XML? Or are they not? Well, it depends. And it's more a flavor of taste and what you like, but for me, annotations are much clearer and it's easier to use. So I'll be using annotations in these demos. So what was new in Spring 4? Well, they got a new website. That's exciting, right? Well, even though it's kind of funny to take it up when you go through what's new in Spring, it's actually a major improvement, because it used to be pretty hard to find good documentation on Spring. So they have done a really good job putting this site together, and it's so much easier to find examples and demos and etc. and tutorials. They have Java 8 support. And I'll show you a couple of examples of that support. For example, @repeatable. Rather than doing it the old way where you had to have the annotations wrapped in a wrapper annotation, you can just repeat them. That support is backed by Spring. Those of you who have done some programming with Spring know that they have lots of these callback interfaces. That means interfaces with one method. And that maps really well into Java 8 lambdas and method references. And this is, I don't think they thought of it when they started designing Spring this way. So it's more like by accident, but due to their consistent design, it's a really good fit. They support Java EE 7, but not all of it. The baseline is Servlet 3.0 and JPA 2.0. So it's more like Java EE 6 support with some Java EE 7 specifications. They have Groovy bean definition language. And why? Yeah, for those who like Groovy, it's probably good. It's more concise than XML, but it's just another way of defining your beans. And not even the Spring guys mentioned it when they present Spring 4. They did some core container improvements. For example, in this case, if you have a foo of integer, it will be autowired into I. If you have a foo of string, it will be autowired into S. So you can now actually autowire generic interfaces. They did some improvement in the web domain. Everybody who's programmed REST interfaces using Spring MVC knows that you had to have this response body to say that you actually wanted a JSON or XML body in the response. Now they made it a little bit easier by introducing a REST controller. So you don't need this response body annotation. They have support for WebSockets. And they also have actually better support for WebSockets than the JSR 356, which is in Java EE 7, because they also have sock.js fallback for browsers like IE less than 10. And they also have messaging, which is really good. So that concludes the short Spring 4 introduction. And let's move on to the Java EE 7. The overview of Java EE 7, if you remember the overview of Spring, it's pretty similar. Those boxes in blue here are the new specifications of Java EE 7. For example, batch applications, concurrency, WebSockets, and JSON API. The other specifications were updates to existing specifications. Most notable is JMS, who got an update. It's been in version 1 forever, and now it's version 2, and that's a major improvement. The focus areas of Java EE 7 were developer productivity, HTML5, and meeting the enterprise demands. And the platform is leaner than ever. It has a minimum configuration, and it has excellent annotation support and dependency injection. And that is new compared to older versions. So let's look at the developer productivity. The amount of configuration and boilerplate code has been stripped down to a bare minimum. For example, you don't need a WebXML file, you don't need a Beans XML file, you don't need any configuration file at all to run a real enterprise application. And CDI has been updated, so it's consistent throughout the platform. And there are new annotations like @transactional, so you can have transactional support without EJBs. It's simpler. If you remember the old way of writing EJBs, there were business interfaces and there were interfaces and remote and local and here and there and everything. Now all you need is actually one annotation, stateless, and you have an EJB. So EJBs are actually fun again. There is HTML5 support. That is APIs, for example, for WebSockets and JSON processing to make it easier to meet the demands of modern web development. For example, WebSockets is very similar to JAX-RS. It's one server endpoint annotation, and you have a WebSocket endpoint. And similar for a client if you make a Java client. So it's really easy to write a WebSocket application today. And the third focus area was meeting the enterprise demand. So, and one thing was actually, as I mentioned, batches. You can now run batch jobs in your JavaE container, and that's pretty cool. JMS got an update. So it's significantly less boilerplate code to look up a queue and use JMS compared to earlier. I think I would probably needed like 5 or 6 slides to have this code in JMS 1.0. So who's passed the compatibility test of JavaE 7? Currently, there are 3 implementations. It's Glassfish, which is the reference implementation. It's currently version 4.1. And it's Wildfly from Red Hat, which is the open source version of JBoss. And it's currently in version 8.1. And you also have a Korean initiative called Tmaxsoft. And has anybody used Tmaxsoft? No. That's usually the response I get. But they passed the test, and Arun Gupta did a presentation at Java 1 this year, and he showed demos running all 3 servers, but he couldn't get Tmaxsoft up and running. So it's not easy, it's not very well documented, whereas the Glassfish and Wildfly are excellent. You should just unzip and run, more or less. So let's look at the mixing side of things. Well, if we compare JavaE 7 to Spring, here I've painted in purple these specifications that are covered by Spring 4. And I probably could have painted more of them, but I've just taken those that I'm absolutely sure are there. Spring has other alternatives. For example, for JAX-RS is actually not supported by Spring natively, but they have an alternative, and you can mix JAX-RS with the Spring if you want to. If you look the other way around, here is the Spring overview, and in purple are the boxes that are covered by JavaE. So if you are somewhere in between using these, either purple boxes here or the purple boxes here, you are in the way of maybe selecting a framework, and this is where you probably should mix them, or shouldn't, we'll see. Aspects is some sort in JavaE, but not as good as in Spring. The major difference between JavaE and Spring is that JavaE runs in a package as, for example, a war file. You have your classes there, and it just lives in the container. It depends on the container, but it doesn't have to bring the container with it. So it's a very small footprint on this war file. If we look at the Spring counterpart, you actually build the Spring container in the war file, and you bring it with you. So the footprint of this war file will always be bigger because you bring in Spring stuff into it. So that's a major difference, the context they run in. So if you want to mix these two ways of doing it, as we saw, they run in different contexts. We need some kind of glue in between there, right? So for example, if we have a JavaE 7 application, we have a couple of beans in it, we're using CDI, we have a Spring component, which is using the Spring equivalent order wiring, and then we somehow want to inject something from Spring. And that is what we're going to have a look at in this demo, how to do this. And the other way around. If we have a Spring application with a couple of beans in it, they are injected as Spring beans, and we have some CDI beans in the separate JavaE component, and we want to be able to auto-wire them in. So this example is what we're going to also check in the demo. So if you've been sleeping to now, then wake up. This is where we're going to look at some code. So first, we're going to integrate a Spring 4 component into a JavaE application. And then I'll just switch to my IDE. So what I have here is a simple JavaE 7 application. It has no configuration except from the Wildfly configuration file, which just says the context it's going to run in. I'm going to do the examples using Wildfly. We have a simple REST resource, which just answers the count path segment and write out hello and has a counter that is injected and just increases this count and has some logging. The counter is just a normal singleton, and it just counts the next. So there's no magic here, it's very simple. And the actual count object is just has a message and some counts. So if we look at the POM file for this one, it only has one dependency, and that's JavaE 7, and it's provided. It's a very thin application. The configuration for this project is just that I want this to listen to /API. This is just plain JAX-RS. So if I run this one, it's going to be a little slow now since Wildfly wasn't started. But hopefully I won't need to start it again. There, we're up and running. So let's have a look. And as you see, it counts every time I hit refresh. There's no magic about it. So what I want to do now is to integrate a Spring component in here and see how we can mess that up. So then I'll just, before I do that, I'll just show you the Spring application which I'm going to use afterwards to inject a JavaE component into. So we can have a look at the similarities. For the Spring application, the war file is also pretty easy, but it has a couple more dependencies. And it packages the Spring context and the Spring web MVC into the war file, and it relies on the servlet 3.1. This is because I'm running in a 3.1 servlet container and Spring supports 3.0, but this one can be provided. The actual count resource is very similar. Here you can see I use the REST controller, which is new in Spring.4. And this is how you map using Spring. I map count to a get method, and I produce JSON. And this one has an auto-wired counter. And the counter in this case is just a Spring component. And it also just increments. And the count object is the same. The configuration for the Spring is a little bit more than JavaE, because here I actually need a WebXML file, or as I've done here, a web application initializer, which is an equivalent of WebXML. And what I do here is that I set up a dispatcher servlet to listen to API. And I load the Spring context, which is this one. And that is just the component scan. And also this, which is new in Spring.4, enable web MVC, which you earlier had to actually have an XML file that declared your servlet and etc. But this is all you need. So if we jump back to the JavaE and want to inject a Spring component in there, I'll just jump in Git here. Let's first look at the POM.xml file. What I need to do here is to add a dependency to my Spring component. So now I added a dependency to a Spring component, and my Spring component looks like this. It has a configuration file. It could have been an application XML or a Groovy file or whatever, but in this case, it's a Java config. I have a simple Spring counter, which is a Spring component, and just counts the next. So it's very similar to the JavaE counter I'm using directly from the resource. It's just a replicate of that. And I also have a more awesome counter, which actually uses the Spring context. But the only thing it does with it is just to log the beans. Just show an example that I'm actually using the context. And it's auto-wiring in this simple counter, which it uses. So here I have a dependency between the Spring beans. If I go back to the application and look at the configuration, now I need to have a producer so I can make these beans, which are managed by Spring, available by CDI. Right? So what I do here is just a very simple approach. I have a single class which produces a simple Spring counter, which I just instantiate here. That's a very, very simplistic approach. So let's see if that works. Then I can go into my resource, and I can inject this bean and set the simple count. Right? So all I've done here is to create a simple producer that just instantiates a new a simple counter, and I use it. And it should be deployed. So replace deployment. So if I go in here now and press refresh, you see that the simple count is also counting now. So far, so good, right? So what about the awesome bean? This one uses the simple bean with auto wiring. And that is not supported out of the box by CDI, because that's a Spring kind of thing. So for the awesome bean, I need to do a little bit more cumbersome thing. And what I need to do here is to actually get hold of the Spring context, which is an annotation context, as you remember, and register it and refresh it. So now I have the Spring context. And then I can write a producer method that looks up the awesome counter from the Spring context. So if I go back to the count resource, and now I should be able to inject the awesome Spring counter and use it. And I said, replace deployment. So it's pretty fast when it's JavaDay. And if I start counting now, you see that it counts. But there is something wrong here, isn't there? Because if you see at the simple count, that is counted by the simple counter, but the awesome count is also using the simple counter, so shouldn't it be counting like 2 steps at a time? Let's look at what's happening here. What I'm doing is that I have my resource, I've added the Spring 4 module, I have the awesome counter, which auto-wires in a simple bean. I inject the awesome bean, and I inject the simple bean. And I end up with a simple bean managed by CDI, and a simple bean, a copy of it, managed by Spring. So what I really want here is to actually inject this one. Right? So if we go back to the code and see how can we do that. Yeah, it's not that hard actually, because you see that we already used the context to get the awesome counter. But for the simple counter, we're actually managing it here. So it should actually just be to and now this one should be managed by Spring. So if you go back and press refresh, you see that the awesome count is actually counted because it uses this one to count up, so it jumps by 2. What about this one? Can we run it without using the Spring context? Well, this one will get you into trouble, because CDI doesn't know this. You can probably manage to do it in some way, but that would be a pretty much hack, so don't do this. So the other way around, if we want to integrate a JavaDay 7 component into a Spring 4, how do we do that? Let's jump back to the code. And let's look at the JavaDay component. This is a singleton, which is just like the Spring component. It just has a counter and it increments for every hit. The awesome counter is a little bit more awesome because it's an EJB. And it uses the simple counter to count. Apart from that, it actually is not using the container in any way. So if we want to integrate this into the Spring application, we need to go to the POM file. And let's see. Oh, this is the wrong one. Here we are. We need to add the JavaE dependency. And as you see, I'll also add the JavaE 7 APIs. I could have added just the ones I was needing, but I'll add the whole package. It's provided anyway since I'm running in a JavaE 7 container. So if we look at this, and let's just try the very simplistic approach here as well, to just in the application config, this is similar to having an XML file where you declare your Spring Beans. But here you use the Java way of doing it. And I just instantiate the simple counter. And in my counter resource, I can auto-wire it and count the next. Let's just run it. So it's deployed. It's a bit slower than the JavaE, but it's still pretty okay. And as you see, this one also counts as it should be. So if I want to inject the EJB into Spring, then I can use the @EJB annotation. Since I want to take advantage that it actually is an EJB, and just inject it like this. And if we look at it here, okay, I'll have to deploy it. I know it's counting, but we have the same mistake as we did in the other case, right? Because what I'm doing here is that I have my resource, I have my awesome and inject, but they're managed by different context. Right? What I really want here is for Spring to auto-wire this one in. So let's see how we do that. Then, as in the JavaE example, I need to get hold of the CDI context. So what I do here is actually to get hold of, use the initial context. There are several ways of doing this, but this is one way. I use the initial context to get the CDI bean manager. And then I can use the bean manager to get a reference to my bean and return the actual bean. So if I, rather than instantiating it here, I can use my new method This can be done by name or whatever, but now I'm doing this by type. And I don't have to change anything here to the @autowired. If you start it now, you see that it counts correctly. So it's important to know how to manage your contexts. But what about this option? What about letting Spring handle it all? That's possible. Let's see how to do that in code. Then, rather than using EJB map name here, I'll just auto-wire it. And I actually need to go back to the other one because I don't want to look it up from CDI. And I'll look up the awesome bean the same way. Right? So now I'm instantiating this one and this one. If I now run it, okay, something is wrong. Maybe I need to deploy it. This is the demo ghost. So now it's counting correctly, but it's managed by Spring. Why is this dangerous? That is because we don't know if this one actually, it is an EJB actually, but here we're just using it as a normal POJO. So if this bean actually depended on the fact that it is an EJB, then this would cause problems. So don't do this either. I'll just switch to there. So that concludes the demo, and let's summarize a little bit. So Spring and Java EE, they actually solve the same problem. They overlap a lot, the frameworks, and they provide very much of the same support. You can actually say that Spring 4 is nearly an implementation of the Java EE 7 spec. But it's not there yet, but they're getting there, and they're actually already implementing things that will be part of Java EE 8, such as JCache. It's supported by Spring. Java EE require less configuration and less dependency, and that means you get a smaller, leaner WAR file, which again makes deployments faster. And there is a less risk of actually getting some dependencies in that you don't have control over. Like everybody who's worked with Maven know that transient dependencies may cause problems. With Java EE, you don't need any of those dependencies. Spring 4, on the other hand, is more portable, even across Java EE containers. Because if you move an application between Glassfish and Wildfly, for example, both are Java EE 7 compliant, but you may get different results because they use different implementations of the specification. So it's not necessarily because it's a specification always, even though it should be. But since Spring brings the context with it, it is more portable. And you can also run it in a non-Java EE 7 container, such as Tomcat. using Spring from Java EE is safer or easier maybe. And the fact is, since the Spring component brings its container with it, and you can interact with that container to get the reference to the beans in the container, they are initialized properly because Spring takes care of that. Doing it the other way around, you actually aren't in that much control of how it's going to be used. Like the example with the awesome counter, that is an EJB, but you can do it without knowing that it is an EJB, and it depends on the container, or potentially can. So mixing Spring and Java is possible, but you need to know what you're doing, and you need to have control of the contexts the beans are created in, and how you get hold of them. So, favor one framework over mixing. And only mix if you need to. So start out with just either Spring or Java E7 and stick to it. And if you have to integrate something in, it's possible, but you need to be careful so you don't mix the context the beans are running in. The sources for this demo is on my GitHub. The slides will be distributed afterwards, so you don't have to write it up. If you want to discuss, comment, or anything, just Google or tweet me or do whatever. So, okay. That was my content for today. Okay, there it is. So thank you very much for having me here. It's been a pleasure, and I enjoy being here in Kiev, and you are a great audience. And I think a couple of minutes for questions if you're not hungry and want to go out for lunch. Yes?
Do you use it in production? So it seems like too error-prone to use in production.
The question is, do I use it in production? And the answer to that is no. Yes?
Can you describe some use cases when it is actually necessary to mix the two containers?
Okay. The question is, can I describe a use case where it's useful to mix the containers? And the only thing I can come up with is actually an example where you bring a Spring component into a Java EE container. And that could be if you find some third-party product that are implemented using Spring and depends on Spring and has its own context, you can bring it into a Java EE application and use it as it's supposed to be. So that's a very okay use case. I wouldn't do it the other way around without actually knowing what it is. And if I develop both components myself, I develop them using one framework. But if you have a third-party library that you want to use in your application or need to use, that's a good use case for it. But make sure that you get hold of the beans and use this component as it is intended. So if it is a Spring component, go through the Spring container to get it. Okay? Thank you.